Hello friends, this video on probability part 4 is brought to you by examfear.com. Before watching this video, you should have watched video probability part 1, part 2, part 3. Let's take example of axiomatic approach of rig coin. A rig coin where tail occurs twice as head occurs, we have to prove that any probability is greater than 0 of all the events and less than 1. So we have to prove this. Also, we have to prove that sum of probability is 1, and for any event E, PE is equal to sum of probabilities in this, and P5 is equal to 0. Let's prove this. In this case, we have this is head, this is tail. So if this occurs once, this occurs twice. So probability of head is equal to 1 by 3, and probability of tail is equal to 2 by 3, because tail is occurring twice for every 3 times throw and head is occurring once for every 3 times throw. So we observe that these two values are less than 1. So this is proved. This guy is proved. It is greater than 0, less than 1. Also, when we add these, 1 by 3 plus 2 by 3 is equal to 3 by 3 is equal to 1. So this is also proved. Since we can't take any event because there are 2, so, or we can say, let's suppose probability event is head or tail. Head or tail event is, if you add this probability of this is equal to event of this is equal to probability of H, P of E is equal to P of H plus P of tail is equal to 1 by 3 plus 2 by 3. That is probability of event A or B is equal to 1. That is true also. Now we have probability of phi. Let's suppose we assume that we get electric shock when we throw a coin. That never occurs. So probability of that event is 0. Let's take one more example wherein we are having axiomatic approach for rigged dice. So a rigged dice is thrown, which we are wrong actually. A rigged die is thrown. Here a rigged die is thrown. A rigged die is thrown, which has only odd number. We have to prove all this. So the sample space here will be 1, 3, 5. No, the event, the output will be this. The total event is, total space is equal to 1, 2, 3, 4, 5, 6. So when we see the probability of this is, let's suppose X, this is 0, this is X, this is 0, this is X, this is 0. For every time we throw a die, we get 1 by 1, 2, 3, 4, 5, 6. There are 6 items. The 0 actually. So we have only 3 items. So probability of 1 is equal to 1 by 3 because there are only 3 outcomes. Probability of 2 is 0 because there is never we get 0. Probability of 3 is again 1 by 3. Probability of 4 is again 0. Probability of 5 is 1 by 3. And probability of 6 is again 0. This is the probability we have. Probability is total outcome by total outcome. So total outcome is 3, 1, 3 or 5, and favorable outcome here is 1. Here it is 3, 1 times. That's why we got this. Now let's prove this, that any probability is greater than 0, less than 1. So we know that all these are greater than 0, greater than equal to 0 or less than 1. So this is proved. Sum of all this is equal to 1. Now let's add all this. We'll add 1 by 3 plus 0 plus 1 by 3 plus 0 plus 1 by 3 plus 0. If you add this, this becomes 3 by 3 and this is equal to 1. This is also proven. Now let's take any event E, where we say that the output is a odd number. That's a sure event, right? Because we are saying it's an odd number. So when you say P of E, this is equal to E is an odd number, so it is equal to P of 1 plus P of 3 plus P of 5. So this becomes 1 by 3 plus 1 by 3 plus 1 by 3 is equal to 1. So this is also correct. In the die is rigged, it gives only odd number. I want to know the probability of 2. That is 0. Because this is something which is not there in the output. So this becomes 0. the coin is tossed twice, rig coin, and we have to find PE. So in this case we see P, first we'll check first whether it is axiomatic approach or not. PH, if the coin is tossed twice we get HH, head tail, tail tail, or tail head. If we add probability of all this, it should get 1. PHH is 1 by 4, ST is 1 by 7, 2 by 7, and 5 by 28. This is the whole sample space. Let's add this. So when we add this, what we get is, I'll make 28 common. So it will be 7 into 4, 28, plus 7 into 4, 28, 4, 8, plus 5. So I get 7 for 11, 19, plus 5, 24 by 28, and this is not equal to 1. So that means non-axiomatic. Since sum of all the probabilities is not 1, this is non-axiomatic. That means we can't solve this question. Let's take another question. In this question, we have a similar question, but here it is 9 by 8. So let's see first if this is also axiomatic or not. So 1 by 4 plus 1 by 7 plus 2 by 7 plus 9 by 28 is equal to 28 common, 7 plus 4 plus 8 plus 9 is equal to 28 by 28 is equal to 1. So that means it is axiomatic. Since it is axiomatic, we can solve this question now. The first question is either head P of either both head union P of both tail. So this is equal to P of H plus P of tail minus P of H intersection T. So this H is equal to 1 by 4, this is equal to 9 by 28, and H union T is 0 because a coin can't be both head and tail. So this is equal to 4 by 7. This is option 1. Now let's go to option 2. It says one head, one tail. That means P of HT union P of TH. So this is also equal to, this is P of HH, it's PP, HH, TT. This is equal to P of HT plus P of TH minus P of HT intersection TH. This is equal to 1 by 7 plus 2 by 7 minus 0 because there is no common point between HT and TH. So this is equal to 3 by 7. Similarly, for third thing, we are supposed to say both tail P of TT. This is very simple because it is already mentioned P of TT is. Now let's discuss probability of equally likely events. Equally likely event probability is 1 by n for each event. So we'll prove this where n is the number of elements. So let's suppose there's an equally likely event and this is n element. So probability, total probability of that event is equal to small p as p plus p plus p plus n times. This is the total probability. The total probability is equal to 1. We all know that. And these are all single probability. There are n number of elements, single probability. So we say n into p is equal to 1 or p is equal to 1 by. So here what we are saying is there are 6 events and they are equally probable. The probability of each element is 1 by 6. For example, when we throw a die, a normal die without rigged, 1, 2, 3, 4, 5, 6, and both are equal probability. So probability of, let's suppose 1 is equal to probability of 2 is equal to probability of 2, 3 is equal to probability of 4 is equal to probability of 5 is equal to probability of 6 is equal to p, small p. Now when I add all this probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 plus probability of 5 plus probability of 6, it should give me 1. Why? Because I am covering all the sample space. So it is equal to p plus p3 times p4 5, say this P is equal to 1, or 6P is equal to 1, or P is equal to 1 by 6. So all these values has the probability of 1 by 6, equal probable events. So in such case, the probability is 1 by 9. Here we will find probability of A or B. Please note that probability of A or probability of B is A union B. It is not A plus B. Why I am telling you is, for example, A has 1, 2, 3, 4 and B has 4, 5, 6. So let me denote this in the graph. A has 1, 2, 3, 4, B has 4, 5, 6. If I add PA plus PB, I'll be adding the number twice, probability of 4. That's why I'm advised to say P union A intersection B. So this is also a dice thrown. So now in this case, probability of E A is equal to 4 by 6 because there are 4 elements, and probability of E B is equal to 3 by 6 because there are 3 elements. Because probability of A is equal to what? Probability of 1 plus probability of 2 plus probability of 3 plus probability of 4, and all these is equal to 1 by 6. So when you add this, you will get 4 by 6. Similarly for this, you say probability of this is equal to probability of 4 plus probability of 5 plus probability of 6 is equal to 1. This is 1 by 6, this is 1 by 6, this is 1 by 6. When you add this, you get 3 by 6. Now when I say P of A or B, if I add these two, if I add 4 by 6 and 3 by 6, what I get? I get 7 by 6, which is not possible because this is greater than 1. So what I do now is, I say P of A union B, that is equal to P of A union P of B minus P of A intersection B. This is total P of A union B. Just remove this guy. Typo here. This is P of A union B. So P of A is 4 by 6 plus 3 by 6. A intersection B is 4. Probability of 4 is 1 by 6. So we'll say minus 1 by 6. So it is equal to 6 by 6 is equal to 1. Similarly, for A and B, it is P, so typo here, it is P of A intersection B. So let's take this example again. We here A has 4 common, so I'll put 4 first, 1, 2, 3, and this is 5, 6. Now when I say P of A intersection B, so it is, or directly you can say, we can solve this another way. So when we say A is equal to 1, 2, 3, 4 and B is equal to 4, 5, 6, and now we'll say, first we'll find A intersection B. So A intersection B is 4. So P of A intersection B is equal to P of 4, and that is equal to 1 by 6. For this, probability is 1 by 6. So we can either solve this way or we can solve that. We can first convert to probability and then apply the symbols, or we can first find the sets by performing operation and then perform the probability. It's one and the same. So probability of A not B is 1 minus PA. For example, all even dice is thrown. So this is 2, 4, 6 and 2, 4, 6, and this will be 1, 3, 5. So when you say that, when you find A dash is equal to U minus A, and U is equal to 1, 2, 3, 4, 5, 6. From this you are subtracting all even 2, 4, 6. So you are getting, what you are getting is 1, 3, 5. So this is the probability of not of A. Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors, and much more. Thanks once again.